Good afternoon. Welcome to Build Day 2. I'd like to tell you a little story. We were getting ready for Build, getting ready to show some of the stuff that we have here today, and I was in Vittorio Bertacci's office. Do you know Vittorio? How many people have met Vittorio? Do you know who I'm talking about? Vittorio's a very colorful fellow. He's been working in identity security for a very long time. And he thought, I'm going to build an application that shows the power of the identity stuff we're doing and some of things like the Office 365 APIs, and his eyes were sort of pie plate wide because he had just finished writing an application that called the Exchange REST API, and he wanted to think up something, and I think he showed this yesterday, where you take all of the email you've got in the last week, find all of the images that were attachments, and show them on the screen. And it was so easy to do. He was gaping at me going, it's so easy. Like, imagine you could do these sort of things. Imagine you could get a list of all the people you've met with in the last month by querying your calendar and taking that information. You wanted to use it for something. And it occurred to me at that moment as I was standing there in his office that maybe now the most difficult thing about doing this was authenticating to the API. And then it's just a REST API after that. How hard could it be? Maybe the only obstacle left to clear is the authentication part. And the good news is that we have cleared that obstacle, and I'm going to talk about that today. My name is Stuart Kwan. I'm a program manager in the Azure Active Directory team. I'm going to talk about the work that we've been doing with Azure Active Directory, with developer frameworks, with protocols, to help you unlock the value in your APIs and your applications for organizational users, people who are in Active Directory. There are many people in Active Directory. Scott Guthrie talked about that a little bit this morning. We want to enable those people as easily as possible to get to your APIs, to get to your applications. So we're going to go through what does an application look like today, the gross anatomy of today's application. It's a little different than when we started building Active Directory 10, 15 years ago. I'll talk about what is Azure Active Directory and the role it plays, and then we'll go through a series of scenarios one by one and talk about how they work. In this presentation, you're going to see a lot of swim lanes, a lot of message sequence protocol stuff, so you know what's happening under the covers. If you want to see the code that's written to make this work, at the or near the end of the presentation, I'll tell you where the samples are. They're available now. You can get at and you can go look at them. I encourage you to go to one of Vittorio's talks. Of course, he had one yesterday, so you can wait for the Channel 9 recording of that, or you can go see the one he has right after this for building web applications so that you can actually see the code. So this is going to be flying at a particular level because there's a lot of ground to cover. And then I actually have a special guest. There's a company, maybe the biggest company that you don't know about yet. It's number 14 on the Fortune 500, and it's called McKesson. And I have a fellow, a developer, Lucas Adams from McKesson. He's going to talk about what they've done to integrate with Azure Active Directory with their products. And I'll wrap up just by talking about what we're going to be doing moving forward with our libraries, with our protocols, so that you can light up your applications. So what does an application typically look like today? Well, applications really haven't changed that much from maybe 10 to 15 years ago, but the environment has. We've always had web apps. We've always had, or actually, we've always had APIs. Now we have web APIs that are making it much, much easier to program to your applications. But now we have mobile clients, lots of different kinds of mobile clients. We've got server applications that want to call your web API. You want to centralize the logic of your application in the web API, so you want to make your web app more of a thin veneer that's just catering to the browser clients. Try to move all of your logic as much as possible into the web API. And then you want your web API to be able to call other downstream web APIs. And this is all happening on premises. It's happening in the cloud. It's happening in .NET, Java, PHP, Node.js, on iOS, Android, Windows Store, .NET, everything you've got is happening here. How are we going to make authentication work in a way that's understandable and workable for all of these different cases? We'll find that out today. I'll give away the secret right now. It's all just some standard protocols, and they're ones that you've probably heard of before. There's a lot of OAuth 2 on the screen here. OAuth 2 is something that's being used by many, many different companies, many, many different platform vendors. It's nothing really particularly new. I'm going to show you how we're going to be using that today. For the browser talking to a web application case, there's some familiar protocols there, SAML 2.0, WS Federation. Those are relatively popular in use today. But there's also a new emerging protocol called OpenID Connect. Have you heard of OpenID Connect? Okay, yeah, good. It's pretty cool. It's pretty hip. It's simply a layer upon OAuth 2.0 so that you can do web sign-in. which makes it very easy to understand this all when we're done. Now, if all you wanted to know was, okay, those are the protocols, you can now get up and leave, that's fine, we're all done. But if you want to see how it works, let's dig in. Before I do that, though, I want to talk a little bit about Azure Active Directory and the role it plays. So we know, or we've realized, that we need to build identity services in the cloud in order to help light up things like cloud applications. So Windows Azure Active Directory is a cloud-based identity service, and it serves a couple of functions. First of all, it has basic identity services in it, like authentication, directory services, identity management. You can go in, create users, create groups, put users in groups, set users' passwords, etc. All of that running in a cloud service. It specifically caters to organizations. So an organization, I'll always refer to our great friends Contoso, who are on the cutting edge, and they use all of our latest technology, if you might have noticed. So Contoso wants to use cloud applications so they can get Azure Active Directory as a way to manage access to their cloud applications. If Contoso has an Active Directory on premises already, they can extend it to the cloud, and they can treat that directory as one, but they don't have to have on-premises Active Directory in order for this to work. They can simply go to the Azure portal, and they can get themselves an Azure subscription. They've got an Azure Active Directory. It's as simple as that. The APIs that you're going to find on Azure Active Directory are not like the ones you'll find on Active Directory. Active Directory has things like Kerberos and LDAP, which aren't really very cloud-friendly, aren't really very web-friendly. The APIs that you'll find on Azure Active Directory are REST, HTTP, and these other standard protocols I talked about based so that we can get the maximum reach to all those different kinds of applications I was talking about earlier. But the bottom line here, if you're a developer, is what we're trying to do with Azure Active Directory is take responsibility for managing identities away from the application so you don't have to do it. So you don't have to code a bunch of pages for how a user resets their password, so that you don't have to code a bunch of stuff so they can put users into groups. Put that into the hands of the Contoso administrators and the people in the Contoso business. Let them do it. Let them decide when users are leaving the organization or when they should be shut off, and you just take those users right into your application. Just to give you a little sort of idea of how we approach Azure Active Directory, there's a free variant of Azure Active Directory. Yes, it's free. So if you go to the Azure portal, sign up for a trial, you have to put your credit card in today. But once you're in there, if you just use Azure Active Directory features that are the not pay ones, so basic authentication, directory services, then you don't have to pay a cent. We don't think you should have to pay to sign in so that you can use our stuff. We want you to use our stuff. If you use our stuff and you like it, you'll pay for it. But the active signing in is not something we think you need to pay for. However, we have an Azure Active Directory premium offering that we just made generally available today, which gives organizations like Contoso the ability to do things like self-service password reset, self-service group management, all the things that you would find in a typical organization that you need to do, and that we can take, again, out of the hands of the developers, so you don't need to worry about that anymore. The people who run the organizations are going to take care of this. And that's my only plug on the IT pro side of this. Let's move on and drill into the scenarios for how each of these cases work. We'll talk about web apps talking to web browsers, web browsers talking to web apps. We'll talk about native clients talking to web APIs, web applications talking to web APIs, and then finally daemons or servers, or like a web API that wants to talk to yet another web API. All of these scenarios, by the way, are composable, so you can take bits and pieces of them and put them together, and they're all going to still work. Let's begin with the simplest case of a browser to a web application. Many of you are probably familiar with this if you've used something like Windows Identity Foundation before. Anybody here used Windows Identity Foundation before? It's a few. So you're signing people in. They're coming from an identity provider. In this case, the identity provider is the Azure Active Directory. And by the way, there is no Azure Active Directory per se. It's a multi-tenant system. Every tenant has their own logical directory, which is a logical security boundary, and it's impermeable from a logical sense. It belongs to them. There are only tenants. There isn't really a service per se that is Azure Active Directory, just tenants in the service when you're thinking about it from an identity point of view. Now, normally what happens in a case like this is the user's at their browser, they navigate to your web application, and they need to sign in. So they either press a sign in button, or maybe you automatically send them off to get signed in. They get redirected to Azure Active Directory. They do what's necessary to sign in, and then Azure Active Directory sends a security token over to the application, which has in it has in it, anybody? Claims, yes, claims. That's information about the user. The security token is signed, so you know it came from Azure Active Directory, and you can know who issued it. And then you can say, oh, yes, this user is allowed in my application. Away you go. And usually an application, a web app, at that point will set a session in the form of like a cookie. OK? So far, so good. Now, we've done a couple of things to make this scenario even easier than it was in the past. We've been putting code into the Katana project so that we have OWIN middleware that works with WS Federation and works with OpenID Connect now. It makes it a lot easier to configure your application to use Azure Active Directory for sign-in. Just a few lines of code, get the OWIN middleware in front of your application, and off you go. People here familiar with OWIN and Katana? I'm hoping that, yeah. All right. Well, if you are not familiar with it, I encourage you to take a look at it. It's pretty cool, maybe life-changing from a developer standpoint. It really does make things simple. OK, so we've got the user signed in. Now, one does not just get a token from Azure Active Directory. You can't just walk up and say, hey, I want to sign that person in. The application that wants the token needs to be registered in the directory. We don't just give out tokens to anyone who asks for them. So if I have an organization like Contoso, and the application has to be registered in order to get a token, then how did it get in there? Well, some basics now on how we think about the model here, the trust model for Azure Active Directory. We have two different kinds of applications. We have single-tenant applications, which are meant for a single organization. So if you're a developer that works in an enterprise and you're doing a line of business, custom line of business development, you want to build an application that just your users and your organization can get to, you're going to build a single-tenant application. Your administrator can register it for you, or very shortly, it will actually be possible. In fact, I think by 4 o'clock today, it will be possible for any user in that organization to go to the directory and register an application, so you don't have to be an administrator. And when your application wants to sign the user in, it sends them to a tenant-specific sign-in endpoint, login.windows.net/tenant name. And that tenant name can be any one of the names that a tenant has. So when you get if Contoso first showed up and got an Azure Active Directory from us, they would get contoso.onmicrosoft.com, which is a default name. And then they can associate verified domains with that, so they can become contoso.com. And as well, there's an underlying, I'll talk about a little later, tenant identifier, which is immutable and non-reusable, which you can know that that really is Contoso, despite how their name might change over time. But you can put any one of those tenant identifiers into that sign-in URL, and that's how you'd sign in people from Contoso. Now, we also have another kind of application that we call multi-tenant, and the process is basically the same. As the developer of the application, you go and register it in your tenant. So let's say now I'm Fabricam, an ISV, and I'm a developer at Fabricam, and I go and I register the application in Fabricam's directory tenant, and then an administrator can push a switch on that application that makes it multi-tenant. Once it's multi-tenant, it is now possible for users from any Azure Active Directory tenant to come in and sign into that application. However, there's a couple of things that are special about this. Number one, it was really easy in the single-tenant case, if I'm building the app, to know where to send the user to sign in. I send them to the tenant's endpoint. But I don't know who the user is in a multi-tenant application before they've signed in. I need to sign them in to find out who they are. So we have a special endpoint that we call the common endpoint, login.windows.net/common, and that's where you send users. If you don't know who they are, but you're a multi-tenant application, they'll get signed and they will come back to you. There's another thing that happens here, which is, again, the application has to be registered in the tenant before we'll give out any tokens. And we allow the user at this point, when they're signing into the multi-tenant application, to consent to use the application. And when they consent, they see, here's what the application is going to do with your identity. If you're OK with that, say yes. If you're not OK with that, cancel, and you won't go back. Or you will be sent back to the application, but you will not be signed in. And then the person who built the application can further try to entice you to consent, of course, because we eventually want them signed in somehow. But once that happens, once that consent happens, the application is then registered in the tenant. So let's look at the consent. If you watched this morning during Grant Peterson's demo, the CTO of DocuSign, when he signed in to the signing application on his iPhone, there was a brief moment where he saw a consent screen that said, are you OK with this application being able to edit and delete your files, read your files, and then access your directory so it can get information about you? And he said yes, and he kept going. This is the consent screen that people are very familiar with today. If you're an end user, you can consent to anything that is a personal access. So you read my mail, put stuff on my calendar, put files on my OneDrive, or anything else that has been marked personal by the developer of the application. No IT people need to be involved. The user can say yes, and then the application gets registered. The application now has access to that information. Now, there are kinds of permissions that only an administrator can give consent for. So let's say you're building an HR application that manages the employees of a company. So when a new person starts at the company, I put them in the HR application, and then the HR application wants to do things like automatically create a user account for them in Azure Active Directory, put them in a set of groups, etc. That application would need to write to the directory. No person can give, no individual user can give consent to that, but the tenant administrator can. The tenant administrator can also give consent for all of the users in the organization, such that if they decide this company or organization is going to use this app, then they can consent. And now users who come visit the application later don't need to consent individually. They automatically get signed in. So that's consent. All right, what do you get when one of these tokens comes to you? Today, the tokens are relatively skinny. There's some benefits to that. That means they aren't that big when they're getting transmitted on the wire. But we do send information like what tenant is the user from, and here you can see that immutable tenant identifier I was speaking about. At the bottom of the table, there's a thing called an object ID. This is an immutable identifier for the user, and so it's both unchanging and will not be reused. It's safe to use as a security identifier in a policy. Whereas the information in the middle should only be used for display purposes. My name can change, my sign-in name can change. Don't put that stuff into policies, because if I leave the organization and someone shows up and has the same sign-in name, then they're going to get access to something in your application that they shouldn't have, whereas that object ID is not reusable. And this is just a subset of the information that comes in a token. I'll show a more elaborate example a little bit later. And then we're also mindfully adding new information to the token all the time. In a relatively short order, we'll start sending group information about the user as well, so that you can be evaluating that in access checks. We don't send that yet today. Oh, and then we also are looking at this concept we call roles, where your application can define a set of roles, then the administrator can assign users and groups to those roles, and then you will receive a role claim instead of receiving all of the users' group claims and trying to figure out, well, which groups matter. Although if you want to get all the group claims, you can still get them. These tokens are signed with a key, and this is an important point. It's one of these, identity, unfortunately, is a somewhat dry topic. But this is somewhat dry but important aspect of identity. The way that an application can tell that the token came from Azure Active Directory is it's signed with a private key, the public key of which is published in metadata that anyone can access. And in fact, there are multiple keys in the metadata. Why are there multiple keys in the metadata? Because we roll keys, right? So we'll be using one right now, and then at some point we're going to start signing with the other one. Pure security hygiene, just in case a key's been accidentally divulged, just in case someone has cracked the key. We want to keep rolling the key. So your application is responsible for periodically checking that you have the up-to-date keys and you're treating all of them as possible signing keys. So at any minute we might switch the keys switch the key that we're actually signing with that's in the metadata. If you use our in middleware, if you use our samples, or if you use the libraries that we're creating for other platforms, we will take care of this for you, going and getting the metadata, having the keys, and checking on a periodic basis. But if you program directly to the protocol, you have to do this yourself. And if you want, you can navigate straight to that URL that's there. That's the OpenID Connect metadata endpoint. Inside it, you're going to find another URL which points to a bag of keys, and that's where the keys are. You'll get a lump of JSON back when you look at that. Okay, so you have to remember, otherwise, when we roll the key, people will stop being able to sign into your app, and that's a bad thing. I have lots of stories about bad things around sign-in, and if I have time later, I'll tell some of them. All right. Okay, so we talked about sign-in to a web application. Let's talk about a more exotic case now, one that's a little bit more difficult to comprehend, but it actually is straightforward once we get through it. I have a native client application on an iPhone, on an Android device, on a Windows device, and I want to sign in and access a web API for the user. The goal, by the way, the mission, should you choose to accept it, is to get a security token from Azure AD and place it on the authorization header of the REST call to the Web API. That's going to allow the Web API to take a look at that token and figure out who the user is. So how do we go about getting the token? OAuth prescribes an interesting two-step flow. The first thing that we need to do is get what's called an authorization code. Here's what that looks like. The native client application is going to open a browser, and it's going to do a get on the authorization endpoint of Azure Active Directory while providing in query string parameters some information about the request. The client ID, who am I? What is this application? Not the user. What application is this? Where am I trying to go? Who do I want a token for? That's the app ID URI of the target, a URI of the target, logical name for who I'm calling. And then where to send the auth code back to, this thing called the redirect URI. When that browser window is open, the user will now sign in. And how the user signs in is a mysterious thing that happens outside of your application. You are not going to know what goes on here, and some arbitrary set of steps could happen. I'll talk a little bit later about why that's important. So arbitrary steps happen, the user is finally signed in, and then Azure Active Directory is going to return a redirect to that redirect URI with that authorization code on it. And the application is going to look and go, oh, I see the browser navigating to that URL. Stop, close the browser, grab the parameter, and now we have an authorization code. Now that we have the authorization code, we can redeem it for a token that we can use to call that web API. So we turn around and we call now a post to the token endpoint on Azure Active Directory, and we send the same set of parameters that describes what we want to do. Azure Active Directory will check to make sure the user is valid, that this client application is allowed to call that service, et cetera, and that everything is kosher, and then give back two tokens, an access token and a refresh token. The application can then take the access token and use it to call the web API by placing the access token on the header. Okay, so far so good. We'll talk about the refresh token again in a bit. But before we do that, let's imagine we were looking inside Fiddler at one of these requests. What does it really look like? Top of the screen, auth code request. Bottom of the screen, the response. You can see it's a get on login.windows.net. This is the tenant-specific endpoint for contoso.com, but equally well, we could stick common in there. And you can see it's the OAuth protocol authorized endpoint. And I would like a code. I would like a code for the resource parameter, which is the service I would like to talk to. And here's my client ID, that's me. And here's where I want you to send the token back to, which is this sort of unusual, it doesn't really matter what it was, URI that I'm going to be watching for in the browser, and I'm going to grab it. The user signs in, and then finally, you're going to see this redirect to that mysterious place. In this case, the to-do list sample that you'll be able to try if you look it up later, look at our samples. I see that I'm navigating to that endpoint, so I stop the browsing. I grab that code. Here's your code. I can then do the token request response. So on the top of the screen, I'm going to take that authorization code, and I'm going to post it up to Azure Active Directory in the token endpoint. There's the authorization code and the type of grant that's being used in OAuth, my client ID, redirect URI, et cetera. And back comes a hunk of JSON that has the access token in it, the nature of the token. In this case, it's called a bearer token. It has no proof keys in it. When the token expires, both how long it expires and when it expires. And we can use the how long it expires in case there's clock skew. So we can, oh, it says 5 minutes relative to my clock. Great. I don't have to worry about my clock being in sync with the server's clock. We can see who it's for. There's the refresh token. And then finally, there's a thing at the bottom here, the scope, which says what permissions the user has. And then finally, an ID token. The ID token is a token that has information about the user in it. This is an important point. When you get back this access token and when you're at the client, you're not to look inside it, no matter how much you might be tempted. This is sort of like the arc at the end of Raiders of the Lost. Don't look in the, okay, but you're not to look inside it because it's not meant for you. That token is meant for the service. It may be encrypted to the service. So one day, mysteriously, it might be opaque. Today, in fact, it's signed, but it's not encrypted. You can look at it, but don't. If you want to know information about the user, look in the ID token. There's informational stuff in there, the user's name, display stuff. Because you just want to put the user's name on the screen of the native client. You don't want to have some interaction with your server to do that. The ID token does that for you. Okay, now if we were to actually look inside the JOT token, I'm just going to skim by this really quickly. You can see some of the information I was talking about earlier, the tenant ID, the user's object ID is that OID parameter. There's a couple of other interesting things in here because this was a delegated flow. So we can see the app ID of the client I was using. That might be interesting. This is the token, by the way, that arrives at the web API. So you might want to use some of that information for various things. But I was able to decode this by just grabbing a trace and fiddler, seeing the access token, and then there's a fellow that I work with named Caleb Baker. He created a website. You can go just stuff the text into the site, and it'll spit back out a nicely formatted JOT token for you so you can see what's going on. I highly recommend it if you're trying to figure out what's going on when you're building your application. So there's this browser pop-up. And if you are building a native client application, you might not like this browser pop-up, but it's very important. The browser pop-up allows us to have the sign-in interaction with the user be arbitrary, and we can change it without you having to change your client. So if we want someday to, well, we've already introduced multi-factor authentication with a phone. We've already created, as part of the work that we've been doing, things like attack heuristics where let's say a user signs in at an IP address that's in this country, and then 30 seconds later, they sign in 5,000 miles away. That's probably an indication that something funny's going on, and that we want to maybe put a CAPTCHA in or some other interruption into their sign-in process. That can happen inside this web pop-up because you're not paying attention from your application code to what's going on in there, and we can arbitrarily change it. So it's very important that we be able to put this pop-up in front of the user so that we can evolve the sign-in process. Now, with that said, there are scenarios where we know you can't even launch a pop-up. If you've used the Azure cross-platform command line interface on like a Linux machine or on a Macintosh, it's written in Node.js. It can't pop up a browser. It's command line, command line, command line. It can only pass a username and password. So we will be offering username password-based mechanisms for you to sign a user in. But those will fail if anything funny is going on, or if the user needs to consent, or if they need to do multi-factor authentication. It's just not going to work. So it's not going to be as reliable as being able to pop up that UI, but we do recognize there are scenarios where it's the only thing you can do. There's some other cases that we're looking at, like let's say the situation is just perfect. They're on a Windows machine. It's domain joined. They've logged in with a domain account. Their account is federated to Azure Active Directory. You can simply ask for a token and say, well, just try to get a token as the currently logged on user without any interaction. And if that works, give me the token. If that doesn't, great. I'll figure out what I want to prompt the user. So like a Kerberos-based mechanism for that, that's another thing that we're working on. OK, so later the access token will expire. And we expire the access token because we don't want the user to be able to ad infinitum access that web API. They might have been removed from the company, or something might have happened. So we need to be able to do a revocation check every now and then. So today, the access tokens that come from Azure Active Directory last 1 hour. After that hour is up, you'll call the web API, and the web API will say, access denied, token is no longer valid. Now, we don't need to prompt the user now, because we have this thing called the refresh token. And we can take that refresh token, and we can call the token endpoint on Azure Active Directory and say, can I have a new access token? And provided, again, the user hasn't been revoked and the situation is all good, we'll give you back a new access token, a new refresh token, and you can keep going. Now, today, the refresh tokens on Azure Active Directory, the life of a refresh token, hinges around whether or not we can tell if the user might have reset their password. That's the cue that we look at, that if, say, you left your phone in the taxi cab and it has a refresh token on it. Well, you don't know that, of course. People don't know these things. But it has cached access to applications, and it literally has your credentials, or credentials that can do certain things. But it's in the back of the cab. Someone could pick it up. They could get into it. They could use it to be you. So we expect when people lose devices like that, they're going to reset their password. And when they do, we're going to invalidate their refresh token. That's going to cause this refresh token flow to fail. And then the user will have to be prompted to sign in again. Now, if we can tell if you've reset your password, then we can give you a very long-lived refresh token, a 90-day refresh token. And it's actually 90 days, and it has a 14-day you have to use it window before it dies. So if you use it within 14 days, sliding window, we'll let it go all the way to 90. Otherwise, if we can't tell if the user has reset their password because of the way that our infrastructure is laid out today, the refresh token will be 12 hours. So the user will have to be prompted to sign in pretty much once a day. OK, that was native client. Let's talk about a web application that wants to call the web API. There's actually two access patterns here, one that's a direct access pattern and a delegated access pattern. So let's say I'm building a web app, and I want it to call the web API, and I trust that web app to have authenticated the user. We call this a trusted subsystem model. If that's the case, the web app just has to have an identity of its own, and it can use that identity of its own to call the web API. So it can get the token, call the web API. The web API is, if it's going to get information about the user, it's going to be information in the application protocol about the user. It's not going to be information that was issued by Azure Active Directory. This is good if you want a very high performance path between the web app and the web API, and you don't want the web API, or the web app to have to get additional tokens about users. But that's not always going to work. Something like when we're exposing the Exchange APIs, we're not going to allow trusted subsystem callers. We're going to require that your application go get a token for the user to call the API, and that's what we have for the user identity flow at the bottom, or the app plus user identity flow. And we use a different protocol for that. So for the former, we're going to use OAuth, what's called the Client Credentials Grant, and for the latter, we're going to use OpenID Connect. Let's look at this really quickly. So we have the flow with the trusted subsystem. I somehow sign into the web application. That's taken care of. Now the web application wants to call the web API. It can use its own credentials to ask for a token from Azure Active Directory and use that token it gets back, which represents its identity, to call the web API. It's as simple as that. Very straightforward. Now, if I want to do the delegated path, then this new OpenID Connect protocol gives a really interesting way of simplifying the scenario and making it more performant. What we're going to do is we're going to put together signing in the user and getting an authorization code all into one step. So the user goes to, they're not signed in yet, they go to the application, they get redirected to sign in, they sign in, and at that moment they might need to consent. If they haven't used the application before, it's multi-tenant, and if they consent, they sign in successfully. What's going to come back to the application is both an ID token with information about the user and an authorization code. So we can then take that authorization code and we can use it to get an access token and refresh token for that user to call the web API. And we can stash those away somewhere. If you look at the samples that we have, we stash the token away in cookies. So as long as the user's there, they're sending the tokens back to us. We can use them to call the web API. You can store them in a database so that if the user's no longer present, they've gone away, they're not at the browser anymore, you still have the access token and the refresh token. And the refresh token lets you get more access tokens to call that web API over and over again. By the way, something I failed to mention earlier when I was talking about the native client case was all of this protocol stuff. Wow, it sounds kind of complicated if you have to do it all on your own. The good news is that we have libraries that will take care of this for you. There's a library, or a family of libraries we call the Active Directory Authentication Library. Scott Guthrie mentioned this morning in the keynote when we were talking about the DocuSign demo, when we were talking about the mobile services demo. What that API does is it handles all of the protocol interaction for you and all of the caching of tokens and the handling of refresh tokens such that all you need to do is call it and say, I'd like a token for this resource, and it will pop up the UI if necessary, take care of managing all of that. If it's on Windows Store, if a Windows Store application, it'll use the Web Authentication Broker. If it's a .NET application, it'll pop a browser control. If it's on iOS, it'll show a web view control. We take care of all of that for you, trapping the authorization code, redeeming it. You don't have to worry about any of that. It's all taken care of for you. And that was in the native client case. It's also used here in the web application case for that web application to get a token so they can call the web API. In both the OpenID Connect case and that client credential case that I talked about earlier. Okay, now, let's see. Would you like to see it in action really quick? Let's just very briefly show an application, the sample application that you're able to try yourself. Move over. So here, that code is not really very visible. Sorry, I was a little too late getting started. So here we have I've got a .NET application, and it's calling this to-do list service that I've pushed up into Azure Web Services, and the web API that's up in Azure Web Services is using the OIN middleware to process the tokens that come in. So if I want to add an item to the to-do list, the first thing I'm going to do is sign in. Okay, here's that web pop-up. This is all being managed by ADAL. I'm going to log into my tenant, which is handily called squantoso.com. And okay, now I'm logged in. I have a token. If I want to add something to the to-do list, there it's added to the to-do list. All right, I also have a set of web applications I've posted up. And this particular application uses OpenID Connect that I was talking about earlier. You can't read that at all, trust me. And, but it also can talk to the to-do list. So let's go and talk to the to-do list. But before I can talk to the to-do list, I'm going to have to sign in, full page redirect to sign in like we talked about earlier. Oh, geez, you just saw me. Has that ever happened to you before? I guess I have a limited time now. That's on the recording. All right, I've signed in. And actually, you know how you go to these sites today and you create passwords and they say, you know, weak, medium, strong. That password is strong. It's like one of my favorites. Okay, so now you can see I've back to the presentation. I've used OpenID Connect to sign on. The application got an authorization code. It used it to get an access token. It called that same API as me, and there's the foo to-do list item that I put up. And then very quickly here, let's flip over to this other device I have, which is a fancy one. You can't see me typing that, right? Okay, and I'm going to go over to Xcode here and start up an application. Oh, good heavens. So you can tell that I'm not, I'm new to Mac development because I'm trying to find the button to start the debugger. And what's that? No, someone seriously tell me. Oh, debug. Product and run. Oh, look at that. That's okay. It's running there in the emulator. That's highly embarrassing. Thank you very much for. But because I tried this before I started the session, the ADAL on this particular emulator has remembered that I signed in. So it has the foo item already. And if I were to go ahead and add another task here, of course, what do you add when you have a foo task? You add a bar task. So we add that. Now, there's a little bug in this where I have to refresh it to get it. But then we go back to this particular set of applications. If I refresh in this browser, there's the bar item, and I can add another one here, Baz, and then we'll see all three of them show up, of course. So this is a very simple demonstration. You saw the sign-in. It was very simple for me. This was a single-tenant application, so there was no consent involved. If you want to learn how to build a multi-tenant application, go see Vittorio's talk that's right after this one, or watch the recording later, or pick up the samples, because it shows you how to do all this. Let's take a really quick peek at the code of this particular native client application, which, again, is very difficult for you to see. But this is the line of code right here where we go and get the token. And this is where the main window is opening. And what I wanted to do when the application starts is if the user signed in previously and we have cache tokens, I want to go and populate the to-do list right away. I don't want to prompt the user to sign in or to have the user press a refresh button or something like that. So what I'm doing is I'm calling ADAL there, that auth context dot acquire token. But I've put this line here at the end, prompt behavior never, which means, well, try to get a token from the cache or from a refresh token, but don't prompt the user, because I don't want them to be prompted immediately when the app opens. If you don't have a token, then I'll take care of that with a sign-in button. So we have ways of controlling the prompt behavior as well inside the application. I'm not going to show any more code. I will talk about where the samples are, though, so that you can grab these if you want after the session. All right, one more scenario to talk about, and then we'll wrap. Or we'll have Lucas come up and talk about what McKesson has done. So we have a last scenario where we have either a daemon or we have a server, so say a web API that wants to call another web API. Imagine that this scenario, or like the one that you saw on stage this morning, where there was the signing application that was running inside the iOS device. It talks to the DocuSign web service, and then the DocuSign web service wants to talk to SharePoint. Well, how is the DocuSign web service going to get a token to call SharePoint. There's no longer a browser there that we can use to go off and get auth codes and stuff like that. So we had to invent a new way of doing that that we call on behalf of. But first, let's say I have a headless device or a batch job, or my favorite is I meet people who have fleets of trucks, or they have factory floor devices that call telemetry cloud service, or even garbage cans that phone home. I've seen these before. It's fantastic. And these things don't have humans around to authenticate for them. They need to have identities of their own, and they can have those identities through the client credential grant that I talked about earlier. So you register the application with its own identity. It uses its own identity to call the web API. That's one very simple case. The second case, where we want to use the user's identity and flow it through, say, from one API to another, we can't use authorization codes, so we'll use this thing called on behalf of. How does on behalf of work? OK, imagine I had that native client. The native client has gone and gotten a token, and it's passed it to the first web API. Now, that first web API has that token as proof the user authenticated to it. So it can pass that token back up to Azure Active Directory along with its own credentials, with its own identity, and say, hi, I'm this web API. I received this token that's addressed to me about a user, and now I want to get a new token to call a further downstream web API. It can get back an access token and a refresh token to do that, and then use that access token to call the downstream web API. Very straightforward. OK, so again, it's the biggest company that you might not have heard of before. McKesson is in the healthcare industry, and Lucas represents a group that does healthcare analytics software. I'd like to just have him come up and tell you about a real-world scenario that's in production today for how they're using Azure Active Directory. Come on up, Lucas.
All right, thank you, Stuart.
Oh, wait,
so,
actually,
yeah, we still need the
first, yeah.
So, who's McKesson? Big Fortune 14 company, lots of revenue. I got to get hurrying because we're getting close to the end. But basically, we're broken up into two sections. We have our distribution solutions, where we distribute drugs, pharmaceutical drugs across the world. And then we have the technology solutions, which is the analytics. We do a bunch of different things with EMRs and all that stuff. Relay Health is one of our big products that we have, and we manage a lot of software there. And that's the part that I'm from. So what do we do? So what we came to do is we want to do healthcare analytics in the cloud. We wanted a way to go after the health information technology for economic and clinical health. Wow, a mouthful. To basically help with meaningful use standards. Meaningful use, I don't know if everyone's heard about that, but this is all these standards that the government's pushed out, and you have to meet these standards to get funding back from the government for your hospital. So they're forcing all the hospitals to do this. So we needed a solution to do this. And one of the things that we always, as many people that I've talked before in this group, so we needed an identity solution. We needed a way to identify a person, identify a user throughout our application. And we were going back and forth between different cloud vendors, and we kept coming back to Microsoft Azure because of Azure Active Directory and the work that Stuart and his team have done. And basically, it was the best decision for us because it was easy to use. All the libraries that they've been developing make it very, very easy to code. I know he's talked about all these different protocols back and forth and all these requests. It's much simpler using their libraries. So now I'm going to demo our application. So as Stuart talked about before, we're using the common endpoint because our application is multi-tenant. We have multiple different users across different organizations. We have different types of users. We have admin IT users from big health organizations. Then we also have your small physician clinics that need to test these certain measures as well. So I'm going to log in and hopefully not type my password in the username.
Ooh. Who would do that?
Mine, too, was very difficult to type. Oh, and I didn't type it right. So here I am doing the sign-in, doing all that stuff back and forth that Stuart was talking about. And we're going to be redirected back to our application with a token. And we're using the Windows Identity Foundation, or the WIF framework, within ASP.NET and VC. And part of that process, we're coming back, we get our token, and then we're going to get pieces out of that token to figure out who that user is and direct them to the correct set of metrics that we're trying to show on the screen. One of the other things, too, that's really easy about using Windows Azure Active Directory is single sign-on. So here, so let's say I'm an IT user, and I want to go into the portal because I'm managing my directory tenant. So I've already signed in the other tab. Now I'm going right over into the portal, and I can go in and see my tenant and manage all my stuff. So here I'm already signed in. I can see, well, here's actually where I have the code deployed, but I can also see my directory. Here's my directory, and in here I can also see here's my application that I wrote. And sorry, that was the directory. And then here's my application. And for developers here, it's really easy also to hook up your local debug environment. So when you're in Visual Studio and you're debugging locally, you can use Azure Active Directory and do all the sign-in back and forth, make it easy to code yourself up. And that's where you can see how I'm doing that here. So one of the other things that we added that was really important for us is groups and roles, which Stuart said that he's promising that are going to come soon. I keep asking him for them. But what we wanted to do, so we have all these different roles, which I'm sure most of your applications do, where we had custom roles for our application. We wanted, we had admins. We wanted people that could submit these measures to the government. And those are special people. We don't want just any user to do it. So we have all these custom claims that we need. So what we ended up doing is we actually used another library from the Azure team called the Graph API. And what the Graph API allows you to do, based on your consent of your application, it allows you to actually read the directory. So I can go in through code, read the directory, and pull out any information I want. I can pull out the users that are in the directory. I can pull out the groups that are in the directory. I can pull out in the future when they had roles and different privileges like that. I can do just about anything I want. If I have different privileges on the directory, I can write stuff back to it. But here is my user in the directory. And here's our little custom app that we have. So here's our little different roles that we have that are specific to us. And I'm assigning these. And I'm using that object ID that Stuart talked about to store that user in our databases with our custom claims and roles. The cool thing about using WIF and the ADO library is that we're able to take through the chain as the token's coming into WIF and we're signing in, we're able to inject these custom roles right back into the token, package it back up, send it back to the app, and you can use it just like a claims-based application. So you don't have to, in the previous apps that we worked on, we'd have to write another database call, go get all your credentials, put them back in. You had all the special logic doing it through that object. Now you don't have to do that. You can just bring it right into the WIF pipeline, inject the roles into the token, and keep on going as a claims-based application. And that's about it. That's what we've done. So we've had great success using Windows Azure Active Directory. And like I said, this stuff's really easy to use. It looks complicated from what he was showing, but it's really not. So.
All right. Thanks, Lucas.
Thank you.
All right. It's a terrible thing as a program manager when you make your product seem complicated. So my salary's going backwards as we speak. But anyway, back to the talk. So let's summarize. We're using industry standard protocols to light up all these different kinds of applications, the different form factors of applications. Our main focus is on OpenID Connect. It's on OAuth. And the tokens that we're passing around are called, we call them JSON Web Tokens. It's also an emerging standard in the industry, sometimes called JWT or JOT. For short, a JSON serialized security token with a very simple signature mechanism. We are creating, along with these industry standard protocols that you can code to directly, we're creating libraries that help you with the getting of the tokens and the verification of the tokens on the client side and the server side. These are all going to be open source. Many of them are already open source. The rest of them are coming, so that if you want to contribute back, or if you want to fork it, if you want to take it and do what you want to do with it, you're welcome to do so. We're here to make sure that you're able to use the service, and we welcome your contributions back if you would like to do that. We have a .NET library, a Windows Store library, iOS and Android libraries that are available right now. On the server side, I talked about the work that we've done in Katana, and then we're also working on Node.js and Java and PHP. Not all these things are ready yet. Some of them are, but they'll be coming out over time as we just continuously push this stuff up onto GitHub under the OpenTech, the MS OpenTech banner, our open source banner. For a sample for every scenario you saw today, you can go to github.com/AzureAD-samples. So we have the native clients, we've got the web apps, I've got the trusted subsystem model, the OpenID Connect model, multi-tenant applications, iOS, Android, it's all there. Please go ahead, take a look, fork those repos, and get to work on them and see how easy it is to build all of these applications. We're looking forward to seeing you there. And that pretty much wraps it up. So for today's applications, we need a new approach to how we do authentication that works with the wide variety of devices that are out there, the wide variety of server platforms that are out there, the fact that applications could be on-premises or cloud now. And we're doing that through industry standard protocols, through open source libraries, and we hope to help you unlock that value that's in your application by clearing that last obstacle that is, how do you get users from organizations signed in to your web apps and your web APIs. Thank you very much. I hope you enjoy the rest of Build.